Hello class, this is lesson 6-2 about solving multi-step inequalities. So again, let's go over all of the steps. Get rid of your parentheses is always the first thing. Second step is to move your variables to the same side. I like moving it to the left, that's up to you. You do that by adding or subtracting on both sides. The third step that I want you to remember is to get rid of the lonely number. Okay, that number that's by itself, get it away from your variable. You do that by adding or subtracting. And then the final step is to get rid of the leech, the number that is sucking the life out of that variable. It's attached to it. So you either multiply or divide to get rid of it. And finally, you need to remember that if you are multiplying or dividing both sides by a negative number, that you flip your inequality. So let's go ahead and get started with some examples. 88 plus 10g is greater than 138. So I'm going to subtract the lonely number on both sides. And I'm left with 10g is greater than 50. Now I can divide both sides by 10. That's the leech. And g is greater than 5. So this one was pretty straightforward. It was 2 steps. So now to graph, I'm going to plot my 5 and my negative 5. I don't need to be more extensive than that. It's going to be an open circle on 5, and I'm going to shade everything that is greater than 5. So going to the right. So let's plug in a test point. So maybe, how about let's plug in the number 10. So 10 times 10. And so that's 88 plus 100. And I want to know if that's greater than 138. And that's 188, which is definitely way bigger than 138. So it works out. All right, my next one, if you notice, I'm going to add 6 to both sides to start to get rid of my lonely number. So that leaves me with negative x over 4 is greater than positive 1. And now I'm going to look at that number, negative 4, I'm going to include it. So that's what I'm going to multiply on both sides. And then I have x on one side, negative 4 on the other side. And if you remember, since I multiplied both sides by a negative, I need to flip my inequality. So x is less than negative 4. That'll reflect all of my solutions. So on my number line, I'll go ahead and plot an open circle on negative 4, and I'm going to shade everything to the left, everything that is less than negative 4. So now I can go ahead and pick a test point. So how about this time, why don't we pick, I don't know, negative 12. So I'll plug that in, and notice how there's a negative on the outside also. So that's really positive 12 divided by 4, which is 3, and 3 minus 6 is negative 3. And that is greater than negative 5, so I'm all good. Let's look at 2 more examples. Now, if you notice, I have an expression over the number 5. So everything on top is actually locked in on the top. So there's like invisible parentheses there. So I need to first remove the 5. So I'm going to do that through multiplication. So then I am left with 2x plus 4 is less than negative 20. And now it looks like a 2-step inequality. Let's subtract the lonely number on both sides. I'm left with 2x is now less than negative 24. Final step, let's divide by 2 to get rid of the leech. And my final answer is x is less than negative 12. So now I can go ahead and plot this on my number line. I have 0 and 12 and negative 12. It's going to be an open circle on negative 12. And it's going to point to the left, every number that is smaller than negative 12. So we're almost done with this. Let's go ahead and pick a test point. I'm going to pick something really far on the left-hand side, like negative 100. Okay, let's plug that in. And I'm going to divide by 5, and then I'm checking to see if this is going to be less than negative 4. So 2 times negative 100 is negative 200, plus 4 divided by 5. Again, everything on top is locked in until it's simplified. So that's going to leave me with negative 196 divided by 5, and I want to see if that's less than -4. And this is going to be a decimal, which is fine, -39.2. And that is definitely smaller than -4, so it works out. So for our final problem, it's kind of complex, so I'd like you guys to really follow along. Again, everything on top is trapped in, so I need to multiply both sides by 3. When I say both sides, that means everything on the left-hand side also needs to be multiplied by 3. So now it looks like it's further complicated, but it really isn't. Let me just show you. So let's rewrite it. 3 parentheses p plus 2 is less than or equal to 5p plus 8. So that's broken free of the parentheses on the right. Now let's use the distributive property on the left to get rid of all of our parentheses. So this leaves me with 3p plus 6 is now less than or equal to 5p plus 8. Okay, now this looks more familiar. Let's move all of our variables to the left. So I'm going to subtract 5p on both sides. I'm left with -2p plus 6 is less than or equal to 8. Let's subtract 6 on both sides. Let's get rid of that lonely number. So then I'm left with -2p is less than or equal to 2. And then the final step, let's divide both sides by -2. That's my leech. And so then I have p on one side, I have -1 on the other side, and if you remember, I need to flip my inequality because I divided both sides by a negative number. Whew, after all that, we're done. Let's go ahead and graph it. So I'm going to have 1 and -1. I'm going to have a closed circle on -1, and I'm going to point it to the right-hand side, everything that is greater than or equal to -1. So again, I'm going to pick 0 to make it as easy as I can. So this is 0 plus 2 is less than or equal to 5 times 0 plus 8, all divided by 3. Okay, so I'm left with 2, and then that is 0 plus 8 on the top, divided by 3. So really that is 8/3. If you want to rewrite it, this is going to say 2 is less than or equal to 2.66666, so I'll just put a repeating symbol, and that is a true statement. So we are done. To wrap up this lesson, we're going to look at what words we would use to signify these 4 different symbols in a sentence or a word problem. So the first symbol, which is less than, could obviously be less than, or it could say fewer than, or smaller than, or something else. The greater than symbol, obviously, it might say greater than, it might say more than, larger than, bigger than, there's a variety of different terms that you could use. The third symbol would be less than or equal to. It might also say at most, or there might be something else. And then the final symbol would say greater than or equal to, or it might use the words at least or something else besides those. So here I have 2 examples for us to translate. The first says the opposite of a number divided by 2 minus 17 is less than 7. So the key words there are is less than. And so now I can translate everything else. When it says the opposite, that means it's going to be negative. And it's a number, that's going to be my variable, divided by 2. So I'll put x over 2. Minus 17 is less than 7. And there we go. This second example here says 4 times the difference of 2 times a number and 11 is at most -12. So I have 4 times the difference of 2 different things. It's 2 times x and 11. And at most is telling me it's going to be less than or equal to the number 12. And I'm done. So there you have it. We have one word problem to finish off with. And it says, Alex has $40 to buy movie tickets for him and his friends. If he buys a $10 membership fee, he can get discounted tickets for $5 each. How many tickets can he buy within his budget? So his expenses would be the membership fee and the tickets that need to be less than whatever money he has budgeted. So that's a $10 fee, and $5 per ticket needs to be less than or equal to $40. So that is the inequality to represent this situation. And now I'm going to subtract 10 from both sides, and then I'm left with 5t is less than or equal to 30. And when I divide both sides by 5, I find that t needs to be less than or equal to 6. And this tells me that he can buy up to 6 tickets for him and his friends. And that's it. So I hope that this lesson made sense. Please let me know if you have any questions when you come into class.